So for the next part, we're going to continue after the creating of the spine. We're going to now create the IK-FK arms. And to speed up this workflow, I'm going to show you some scripts to do that. So let's open the script editor. And let's make the joints visible. And let's select the shoulders. And we'll duplicate the shoulders. We'll add the prefix. Modify prefix hierarchy names. Call these IK. Do it again. Duplicate. Prefix. And add FK. Let's open these arms. And everything after the wrist can be deleted. Same here. So we don't have the fingers double. And remove the one to clean up the name. So now it's nice and visible. And what we're going to do now is we're going to generate a blend colors node. We're going to do the connections, and we're going to add an attribute. If that attribute doesn't exist, we're going to create it. Or wait, let's just hook it up to these blenders right away. So let's see where these live. Press F in the outliner. Let's duplicate it and move it up to the hands. Let's give it the correct name. And let's say it's the arm. And duplicate it, paste it to the other side. Also delete the point constraint, we don't need it. So those are the blender boxes. And we're just going to connect the blender straight away to the Translate X. So first off, we want to import the Maya commands. So from Maya import CMDS. So now we have access to all the Python commands that Maya uses. And I'm going to get the selection using the ls command. And say that my selection is true, so this will store everything I selected. So if I print this, and I have my left arm blender control selected, I press enter, and you can see it prints it out. So let's this up a bit, so we can see what it actually prints. Do it again. Yeah. Now I want to create a node. This is the blend. So I'm going to use the command create node. And I want to have the blend colors. And I want to use the selections now. So let's add a comment. So one is IK. So I want to do cmds.connect attribute and then use selection 0, because if we select multiple objects at the same time, let's see where that. So I want to go from IK shoulder to FK shoulder to right shoulder, and then I want to select the blender. And if I just print these, it will print IK, FK, right, and then the blender. Let's just grab this as a comment so we know what we're talking about. So the first selection, select 0, we want to use the rotation and we want to connect that to the blend and then the colors one. And we want to force this connection. So if this connection didn't already exist, it's now added. So now we have the second selection, which will be the FK. So change selection 0 to selection 1, and we want to add that to the second color. And then we want to have the output. Let's just copy these lines again. So the third index will be the skin version. Let's do it. So the blend output is going into the rotation of the skin arm, and lastly we're going to connect our translate X of our fourth selection. So fourth is the blender node or the blender control. So we want to have the translate X of the blender control. So selection 4 plus TX with a dot to make sure that's an attribute. We want to put that into the blend called blender. So now we have IK first, FK second, then the shoulder, and then we have the blender control. And let's select this or assign it. And my list index is out of range because we don't have number 4, we have number 3. Let's try this again. And now it should already blend. I'll rotate the FK up and then I'll use the blender, and you can see they nicely blend. Do it again. IK elbow, FK elbow, the normal elbow and the blender, run it, and then when I rotate this one forward it already blends. So IK wrist, FK wrist, normal wrist, and then select the controller, run, and this should work nicely. Just make sure that's in super rotation and everything rotates. So let's make sure that everything is set to 0 now. Blend it over. This one as well. Close the right arm and go to the left. So in this case we can go IK, FK, shoulder, blender, hit, IK, FK, elbow, and again, wrist, 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 controller, and then I'll go and check with the FK, rotate in a certain position, and blend. So that seems to work. Set it all back to 0. Now for the IK we can make it really easy. Just hide the polygons. Do the same trick as we did with legs. Create a polygon triangle. Place the pivot somewhere in between and scale it up. Go to Control Creator and we'll select the diamond again just to stay consistent. Group it and place it all the way out here. And we can give it a name. So this will be the left arm pole vector. And we'll group it, duplicate it, and send it to -scale in X. And rename the objects. Delete the groups we created. So now we can go and add a rotate plane solver IK. So from shoulder to, oh, we need to do it on the IK version. Select this constraint pole vector and parent it to the IK handle. Now it's moving. Same for the other side. So IK to IK, do a pole vector constraint and attach it. So now this arm moves it. The only thing is we still need to make sure that the rotation of the wrist works. Let's make sure that it's on the wrist itself. Same here, it needs to be on the IK wrist. And then when we rotate this, the hand follows. Then we can already select the IK handles and remove scale and visibility. And for the pole vectors, rotate scale and visibility. Next up is the FK arm. We're going to also create a script because this FK arm works the same as the FK part of the spine. And we don't want to redo all these controls every time by hand. Especially also for the fingers. I don't want to do every part of the joint or every piece of the finger separately. I just want to select something and generate the controls on the fly. So let's open a new tab. And again here, from Maya, we're going to import CMDS. We're going to work on our selection again. It's called cell. Again, list selection and make sure that we get our selection. I want to be able to give it a controller. In this case none, but later on we might want to get controllers, or even now for the FK part of the arms we want to use separate controllers than just normal circles. But then we can give it a name in this controller attribute here, and otherwise we'll just default to a normal circle controller that we just use for the IK arms. So let's go to a for loop for I in the cell. So for each selection, every selection that we made in the selection here, we're just going to convert that object into I as a variable, and that's something we're going to use to generate our controls on. So if I, for instance, use the FK objects we have here, let's just make it a little bit more visible. So I have all the FK objects selected here. I'm just going to print out what I is and print out the selection before. if I run this, you can see I have the FK left shoulder, FK left elbow, FK left wrist, and in order it will print out I as the new variable for each object in this list. Now, to make sure that we have an empty selection after this, because if it might be that some commands that we use a selection as an input, but we want to override this, so we are going to clear our selection. So we make sure that nothing is selected afterwards. And then if we have a controller, so if we don't have a controller, or if we filled in a name that doesn't exist, obj exists, controller. So if we have filled in none, or we filled in a name that does not exist in our scene, we're going to default to the simple circle. So let's make a new variable, controller1, and we'll use circle, which is the default command for the NURB circle, and we're going to use a normal, and I just default to X, as that is our main axis for all the joints, but we are able to adjust these values later on to make sure that they work perfectly for our needs. And I'm also just going to give it a name, and I'm just going to use the name that we just generated here, so FK left shoulder, and then I'll add control in the end, like this. And normally when you generate a controller or a circle like this, you get the object node and the creator node. So I want to have the object node as the controller one. So I'll just add this as a list, or to make sure that the first part of the list comes out. And else, if we do know that we have like a controller filled in here, I'm going to make sure that we duplicate that object and place it in the correct position. So then we have controller 1 would be the duplicate of our selection, and we're going to give that the name as well. And also with this duplicate you get more outputs than you want, so we only want the first output of this list. We want to make sure that it's grouped correctly, so scene.group. We make sure that the group we create is empty beforehand. We give it a name, which is going to be the same name as we had before, but then instead of control we're going to add group to the end, and the group will always return just a single node, so we don't have to give it an index of which node we want to return. This is always a string. Then we're going to parent the object that we have created in controller 1 to the group we just created. So everything needs to be generated on origin, otherwise it will move its position. And then we're going to constrain this object to the right location. So I use a parent constraint from the original selection to the group we have now and make sure that the maintain offset's off. I want to delete this parent constraint, and then I want to make sure that the control we just created is moving and rotating the object we selected in the beginning. So I'm doing a point constraint from the controller to our first selected object. Make sure that maintain offset's off. Do a similar thing, but then for the rotations. And then we want to make sure that the controllers are all nicely parented, like in the hierarchy that I just selected. If we have FK shoulder, FK elbow, FK wrist, I want to have the same hierarchy now for the created controllers that we have. So I want to make sure that we have something in the beginning that says that we have a parent, and if we have a parent, we want to parent it to. If we don't have a parent, then we don't do anything. So I'll just give a variable name pre-parent, and which will always start as none, because we want to have all the base of the or the root of the controllers created at world origin, so we have it nicely added down below here. And then for all the controllers that we create after that, we want to have them parented. So if pre-parent not equals none, then we want to do a parent operation. So group will be added to the pre-parent, and if it is none, then we don't do anything, so we don't do the parent operation. And then for the rest of the lists, we are going to make sure that there is a pre-parent, and that's going to be controller 1, so the newly created controller. So pre-parent is none for the first one. So for the first object, for the shoulder, we're going to create all the controllers, whatever. The shoulder FK controller will be now a pre-parent. So if we go in for the second time, we do have a pre-parent. So the new group, the group of the elbow, will be attached to the pre-parent. So I still have the selection working here. And if let's just test it out. If I just run this, you can see it will generate point and orient constraints, and it created a nicely stacked list of controllers, as you can see here, which are all nicely moving the joint chain. But I don't want to have circle controllers in this case, so let's go back to my original selection. I want to go for boxes, so I select the cube on base that I have here, which is pointed towards direction Y. I'll just go and rotate it so it points towards X like we have in the joints. Freeze the transform, and let's get the controller name, which is curve 4. So I'll just put the controller name in here. Then I'll select the FK in order, and I'll just run the script. As you can see, now we have nice cubes in the correct orientation, and if we blend in between, it will blend nicely. Let's do the same for the other side. So I have these three, run it, and now I have nice cubes in here as well. Then we can do the same for the fingers. Fingers are a little bit different because we do want to use the rotation controls. We want to make sure that they are nicely aligned with the length of the finger, so they rotate like we have the blue line here. So in this case the normal of the circle needs to point towards the z-axis. So I'll just remove the name we have here and make sure that the normal that we have is in the z-axis. Select the joints and run the script, and do the same for the other fingers. And the nice thing about this is, because we generate all the circles instead of duplicating them, we will still have the make NURB circle node in there, so we can change the size on the fly. So for instance, I want to have the first circles we have here. This one. So those are all the circles that control the first joint. Let's just go to the channel box, make NURB circle, and I'll select the radius and then change the size of all these circles. Then do the same for the rest. Select all the circles that we have, all the bigger ones. Go into make NURB circle and change the size. Let's copy the size, as I forgot to thumb controls, and paste it in here. So now everything is nice and clean. And let's go back to the outliner, because we don't need the code anymore. And we can check if this is working the way we want to. As you can see, the controllers are nicely stacked. As for the FK controls, these ones are now oriented the wrong way, but we can go in and remove the show polygons, and you can just select the CVs and make sure that it looks nice. So something like this. And make sure that they are exactly the same. So now we have FK arm and IK arm, all with nice controllers. The only thing we need to make sure now is when we move IK or either FK that the finger controls will follow. So let's make a locator, duplicate it, make sure that this is the left wrist group and this is the right wrist group. And we're going to use the final joint that we have, the skin wrist. Select the wrist group and we're going to do a parent constraint, same for the other side. And then we're going to select all the left controls and parent them in the locator, all the right controls in the right locator, or right locator. And we can parent these to the master controller. And then when we move the IK controller, you see that the controls will nicely follow. And if you blend in between, the controls will still stay on the fingers. The only thing that rests now is the clavicle controls. So I'll just pick out a nice controller for this. group it, select the clavicle, and then do a parent constraint, duplicate it, select the other clavicle, do a parent constraint, this is going to be the left clav control. We have the right clavicle control. And these are going to be part of the chest control later on. But first let's make a connection and clean them up. So they have the right orientation. Scale them in a bit and move them outside. Somewhere here, select the right one and make sure that the translate Y is in it minimized. So freeze transforms, and these are going to be just rotated like this. So we can already select control, select the joint and do an orient constraint, same for the other side. So when we move these, the clavicles will move with them. The only thing we now have to do is make sure that the FK controls follow. And the FK controls is nice when you have the rotation of the clavicle up, that they can stay in the same orientation of the world that they have now, or they follow the orientation local to the clavicle control. So let's add 2 locators for that to make sure that they work precisely. And let's delete the curve that we have here. So I'll create a locator and I'll select the FK control, do a parent constraint, and I'll call this left clavicle local, duplicate it, world, duplicate this one, make sure that I select the right FK, do parent constraint again, rename this, and duplicate and call it world again. And then we have the FK controls here, these two. And we want to add a lock attribute to the clavicles. So we're going to select the clavicles, edit, add attribute. And this one is FK local to world. We want to have a minimum of 0, a maximum of 1. We're going to add the attribute to both controls. Make sure we lock and hide the translates and the scales. So we only have the rotations and the extra attribute. And then I want to make sure that they will always follow the last position of the clavicle. So I'm going to use the local position. So from left clavicle local, I'm going to use the group and do a point constraint. Same from right to the right FK control, do a point constraint. But I will use the local and the world both as an input to the group for the orientation. Because if I go and look in the orientation node, now I have 2 inputs. And those 2 I can blend. So first do the same for the other side. And I'll parent the local one onto the joint. Same on the other side. So whatever I do with this rotation, if I hide the polygons, that local locator will always follow the orientation of the clavicle, and the world one will always follow the one of the world. So these two can be parented to the master one. And then I'll just use a set driven key on the orient constraint to switch in between. So I have the name here for local to world. So local is first on 0 and world will be the 1. So I'll select FK local to world, select FK the orient constraint, and I'll make local first. And then when I set this one to 1 and select the orient constraint, I want to make world second. And then when I rotate this, you can now see that it will follow the orientation of the world locator. But if I blend this, it will now follow the orientation of the clavicle itself. So the animator can choose which option he likes best. And again, do the same for the other side. Set driven key, load the driver, load the orient constraint, and I'll select local as main weight first. Switch over to world. Make sure that the world is now the main weight. Test it out. It's in world. It's in local space. And that's it for the arms. Make sure that we clean everything up we've done so far. So all the stuff that we created here for the right arm, left arm, I can add the FK to the clavicle. Let's see if this still works. It still switches to world because of the locators we used, so that's okay. The clavicles can be parented to the chest control, so whenever we move this, it will all nicely follow. And then the pole vectors and the IK parts will be parented to the master. And if we then go and check with the polygons, we can see it nicely blends in between. And it will always nicely follow. Let's give it all a color. Get rid of the joints. Well, let's hide everything and only show the curves. This one would be red. These would be blue. The wrist and the shoulder FK controls will be all rotations. The elbow could only rotate in a single axis, which is rotate Z in this case. We do the same for the hands. The first two would be open for all rotations, so we can make nice cupping motion with the hands. So all rotations open. And then for the last digits, we will only have the rotate Z open. And that makes it clean on this one. And to make it nice, we can also connect the visibility again for the warning shape we have in here. just to make it complete. And we can do the connection similar as we did with the foot, that it will always follow the wrist. And then we can can start with the neck and the rest of the cleanup.